What we're going to do in lesson 5.6 is we're going to take two decimals and divide them. And we're going to do this using our standard algorithm in order to divide. But let's just review how this would look if we were modeling this as we did in lesson 5.4. I should say 5.5. If I was trying to show 1 whole and 2/10 being divided by 3/10, what I'm trying to find is how many groups of 3/10 there are in 1 and 2/10. So what we would do with our models here is we would show what 1 and 2/10 would first look like. So as you can see from the models, I have 1 and 2/10 that's shown. Now, if I'm taking that 1 and 2/10 and dividing by 3/10, like I said, I'm trying to figure out how many groups of 3/10 there are in 1 and 2/10. Well, I could see right here from the model I have one group of 3/10. I could also see in red I have my second group of 3/10. In yellow I have my third group of 3/10. And the remaining colors that are here in purple, I could see I have my fourth group of 3/10. So as you could see, in 1 and 2/10 there are 4 groups of 3/10. Therefore, 1 and 2/10 divided by 3/10 equals 4. And I could prove that with my inverse operation. 4 times 3/10 equals 1 and 2/10. So that's how we would model that. But we don't always have to model a decimal division. We could solve it using our standard algorithm. Let's take a look at that. The first concept we need to understand is that 6 divided by 3 equals 2. Now, if I multiply that 6 by 10, I get 60. And if I multiply that 3 by 10, I get 30. If I multiply 60 divided by, if I divide 60 divided by 30, I'm also going to get 2. Since I multiplied this by 10 and I also multiplied that by 10, my quotient wound up being the same. Now, I could take that 6 and that 3, instead of multiplying it by 10, I could multiply each one by 100. 6 times 100 equals 600. 3 times 100 would equal 300. And if I divided 600 divided by 300, my answer would once again be 2. If I'm multiplying the divisor and the dividend by the same power of 10, the quotient will remain the same. That's an important concept to understand when we divide decimals. For example, it may be difficult to understand if we have 5 and 6/10 and we're trying to divide it by 7/10. Since we've never really been shown how to divide decimals, we have been shown how to divide whole numbers. Now, what we could do here is we could take this divisor here, and we could take this divisor and turn it into a whole number. We could turn that divisor into a whole number by multiplying it by 10, because if we multiply that decimal by 10, we know that decimal moves over one place to the right, and we know that from our patterns of multiplication. And that 7/10 now has become a 7 whole. Now, just like I showed you with our last examples here, the answer will be the same if we also multiply the dividend by 10. If we take 5 and 6/10 and multiply that by 10 as well, that decimal is going to move over one place, just as it did with the divisor. Now that we created these 7/10, we converted the 7/10 into 7 wholes, and the 5 6/10 into 56, we're able to divide, and we're able to get our answer of 8. And that 8, which is the answer to 56 divided by 7, is the same exact answer to 5 6/10 divided by 7/10. Since we multiplied that by 10 and we multiplied that by 10, we were able to get the same exact answer. Now, if we have 13 2/10 divided by 6/10, what we want to do is we want to take this 6/10 and we want it to become a whole number. And we know if we multiply that 6/10 by 10, that decimal will move over one place, and now that 6 is in the 1 wholes place. Now, since we multiplied the divisor by 10, we would have to multiply the dividend by 10 in order for us to get the same exact answer. So since this decimal moved over one place to the right, we're going to take this, multiply it by 10, and now that decimal is going to move over to the right one place. Therefore, whatever we get as an answer to 132 divided by 6, it will be the same exact answer as 13 2/10 divided by 6/10. So I divide 1 divided by 6. I'm unable to do. So if I have 13 10s being divided into my 6 groups, I know I could put 2 in each group. I multiply, subtract, check, and I bring down. And I'm left with 12 1s. I take my 12 1s divided into 6 groups. I could have 2 in each group, and there will be nothing remaining. Therefore, my answer to 132 divided by 6 is 22. And that will be the same answer to 13 2/10 divided by 6/10, because we multiplied each of the divisor and the dividend by the same number, the same power of 10. One last example. If I have 3 72/100 and I'm dividing it by 1 2/10, what I'm trying to find is how many 1 2/10 are in 3 72/100. Well, the 1 2/10 is not a whole number, and my goal is to get that divisor to be a whole number, and I know if I multiply that divisor by 10, that decimal moves over one place, and it becomes 12 wholes. Now, since I multiplied the divisor by 10, I know I also have to multiply the dividend by 10. When I multiply this dividend by 10, that decimal moves over one place, as it did in the divisor. Now that that decimal has moved over one place, I raise that decimal straight up, and I would divide, like I normally would. If I have 3 10s being divided into 12 groups, I'm not able to do that. But if I have 37 10s, or 37 1s divided into 12 groups, I could put 3 in each group. That means I used 36 of them. And I would have one left over. At this point, I could bring down my 2 10ths, and I could regroup and create 12 10ths. If I have 12 10ths and 12 groups, I could put 1 in each group, which means I used 12 of them, and I have 0 remaining. Therefore, my answer to the original problem of 3 72/100 divided by 1 2/10, the answer is going to be 3 1/10. The key point to remember is, however many places you move the decimal in the divisor, you must move the same number of places in the dividend, and then you divide.